This is lecture 1 part 2. Okay, so today our topic will be the sun and planets, the basic things about the sun and planet which I have left in the part 1, and the second is Titus Bode's law, and the third one is formation of earth and solar system. Okay, so let's start with the sun. We know the sun is one of the important part of our solar system. Without sun, no life is possible in the earth, because it provides lots of things to the earth, mainly light, energy. Okay, so the mass of the sun is 99.85% of solar system. So it contribute 99.85%. 99.85% mass of the solar system. 99.985% mass of the solar system is contributed by the sun. Angular momentum by the sun is 2% of the solar system. The formula of the angular momentum, you have read these things in your class 12 or class 11. This is mvr. This is the angular momentum. Okay, mass, velocity, radius, all those things. So I am not going into detail. When the numerical comes, I will tell you angular momentum in detail. Next, all planets mass contribute only 0.15% mass of solar system. So all other planets like Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, all those planets combiningly contribute only 0.15% mass of the solar system. Okay, because 99.85 mass of solar system is contributed by the sun now. So all planets contribute only 0.15% mass of the solar system. Next, angular momentum of all planets is 98% of the solar system. So angular momentum by all planets is very large. This is 98% of the solar system. Okay, so this is the basic idea about the angular momentum and mass of the sun and the planets. In this content, I have compared the sun and the planets on the basis of angular momentum and mass. So take a screenshot and note it down. So Titus Bode's law. So according to Titus Bode's law, this is the Titus Bode's law, which is A is equal to 0.4 plus 0.3 2 to the power n minus 2 astronomical unit. So what it wants to tell us? So according to Titus Bode's law, this law relates the semi-major axis of each planet outward from this sun such that the semi-major axis A is equal to 0.4 plus 0.3 2 to the power n minus 2. So what is this A? A is the semi-major axis. Okay, and n is the order of planet from sun. So we have to understand here two things, a and n, because these two, a and n, these two are only variable, all are the only numbers now. So we have to understand what is this a, what is the semi major axis, and what is this n, what is the order of planet. Okay, so write down this and take a screenshot. First, let's start with the what is the semi-major axis. Suppose, so this is the Earth's orbit. This is the path which in which the Earth revolution takes place. So the Earth is situated at this position, and the Sun is situated at this position. Okay. So now I am drawing the two imaginary lines, this one and this one, horizontally and vertically. Now look, this one, from this here I have drawn a tangent, and from this distance, this is the distance from this tangent to this axis. So this is the called the semi major axis from here to here. This one is the semi major axis. Semi major axis. So this is the A. We can calculate the distance from the semi minor axis. Okay, this is the semi minor axis. Now you understand the semi major axis. So this semi major axis is calculated in the astronomical unit. You know, I have told in the previous lecture, in the part 1, one astronomical unit is equal to 14951123450. Okay, kilometer. So from this A we can calculate the semi major axis. Okay, now let's move on to the what is the n. So n is the order of planet from where? From sun. Okay, so we know, let me erase this first. If this is our sun, so this is Mercury, this is Venus, this is Earth, and so on, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, like that. Okay, Pluto is no longer considered as planet, this is dwarf planet. Okay, so this is Sun. Now for Mercury, n order is 1. For Venus, n is 2. For Earth, n is 3. Now you can calculate A, the semi major axis. How you can calculate? Now if you want to calculate, just pause the video and you try to calculate first and come back and see my calculation. Okay, first you try to calculate, then tell me the answer in the comment box, then see the answer. answer. Okay, if you are correct or not. Now I am calculating A. So I hope all of you are calculated A. So A is 0.4 is same 0.4 plus 0.3 2. Since we know n is for Earth, n is 3, Mercury, Venus, Earth, n is 3, from Sun, so 2 to the power 3 minus 2 astronomical unit. So it will give rise to 0.4 plus 0.3 multiplied by 2 astronomical unit. So 0.4 plus 0.6, 0.3 into 0.2, 0.6 astronomical unit. Now the answer comes 1 astronomical unit. So the semi-major axis is 1 astronomical unit, which is 1495150 kilometer. Okay, I hope the concept of Tyndall's law is clear. Now if you have any doubt, just comment me. Okay, now coming to the topic, formation of Earth and solar system. So before starting the topic, let us consider the net question, which is asked, I don't remember the year, but it is asked in the net exam. The age of Earth and solar system is Earth is younger, solar system is older. Second, solar system is younger, Earth is older. Both have same age. So what will be the answer? If you know the answer, comment me. So the age of Earth and solar system both are same. Both have formed in the same age. Okay, both have same age. The correct answer is both have same age. The formation of Earth and solar system is simultaneously. Okay. Now let's move on to the topic, formation of Earth and solar system. So I told you in the discussion question that the Earth and solar system came into existence simultaneously. That means both have the same age. Now, how they come into existence? So it must have some process of existence. So according to theories which have developed by many scientists, according to them, so the sun and rest of the solar system, the rest of the solar system, what comes? Planets, satellites, okay, asteroids, comets, all those things came into existence about 4.5 to 4.6 billion years ago. Okay, how they come into existence? So the building material is huge cloud of gas called solar nebula. Okay, so this solar nebula, which is what? A huge cloud of gas, which the scientists call the solar nebula. From this solar nebula, the sun and the rest of the planets come into existence. Okay. Now the cloud collapsed. Why the cloud collapsed? Because due to the shock wave of a nearby exploding star called supernova. The exploding star, you may know the exploding star is a supernova if you watch the Discovery Channel, okay, or National Geographic Channel. You know the supernova, the exploding star. Okay. So the supernova exploded and due to this explosion a very huge amount of shock wave is created. So this shock wave, due to this shock wave, the cloud which is our building materials collapsed and give rise to planets, satellites and other things of the solar system. Okay, so this is the basic idea about the how the solar system, how the our solar system came into existence. Okay, so here this is the important 4.5 to 4.6 billion year ago. I have told in the previous lecture also that this is often asked in the NET, GATE or JAM exams. The age of the Earth and the solar system, 4.5 to 4.6 billion year ago. So note it down. Now I have told you in the previous lecture the formation of Earth or the origin of Earth is divided into two categories. First one is evolutionary theory and the second one is catastrophic theory. Now let's start with the evolutionary theory. Okay, so according to evolutionary theory, the planets evolved during the evolution of sun. Means what? The planets came into existence when the sun was evolving. Okay, when the sun was evolving, planet evolved or came into existence. Second important point is origin of sun and planet occur by gradual process. Means the sun and planets all come into existence by gradual process. That means step by step process they came into existence. So the example is nebular hypothesis. Okay, you must have learned in your BSc first year or first semester the origin of Earth. You have the syllabus in the BSc first year, nebular hypothesis. So if you want to know detail about the nebular hypothesis, comment me. I am not going into detail in the nebula about the nebular hypothesis. So if you want, I will go into detail. Okay. So now let's move on to catastrophic theory. So according to catastrophic theory, the origin of sun occurred before the origin of planet. So some group of scientists say that the origin of sun came into existence before the existence of planet, while some other scientists say the origin, the sun and all the planets come into existence together simultaneously. Okay, so this is group level catastrophic theory, which states that the origin of sun occurred before the origin of planets. Now, second important point of this catastrophic theory is the planets are formed by special accidents or by sudden process, by close appearance of two stars or by collision of two stars. Okay, so according to catastrophic theory, look, this is catastrophic, right? Catastrophic means what? Catastrophic means some accident will happen, some collision will happen. So here the collision between two stars or the close approach of the two stars is happen. So what will happen if the two stars come closer with each other? So let's discuss it. Suppose this is one star and another star is coming from this way. So in this way the star is coming. Suppose it reaches to this point. Okay. Suppose this is a big star as compared to first one. Suppose this is big star. So when it comes closer to the small star, this is small, this is large. So when the star is large, so it must have a greater gravitational pull as compared to the small star. So when it has a greater gravitational pull, it will eject the material from the small star. Okay, the materials will ejected due to the large gravitational pull of this huge star. When the materials ejected, when the materials ejected, these materials became the building material of the other planets and satellites. Okay. So when the two stars collided with each other, what will happen? Materials will ejected, fragments will ejected, and these fragments, these small fragments, give rise to planets. Okay. So this is all about the catastrophic theory. Now the example of catastrophic theories are planetesimal hypothesis, gaseous hypothesis, binary star hypothesis, gas and dust hypothesis. All these hypotheses have its own merits and demerits. Okay, all have some plus point which explain the origin of Earth and solar system, and all the hypotheses have negative points which can't explain some of the points. Now I am not going into detail of these hypotheses, okay, because the video will be very large. So if you want to go into detail, just comment me. I will make a separate video on these separate topics. Okay, thank you. Now I want to tell, I have also a Telegram channel which in the description I have given the channel link. You can join us, and I have given quiz on the daily basis and for your concept